Hello and welcome back to the lab. In today's video, we're going to continue working on the Deja Vu edition of the HP3440A digital voltmeter. When we left off, we had completed the cosmetic restoration of this instrument, and today we're going to begin working on the electronics. So let's go. So even though I don't have the extender for the plug-in module on this instrument, um, by simply removing the top cover, I have access to almost all of the A1 assembly, which I'm sure the problem is located for the range control issue, where I can't select the 100 volt range or the 100 millivolt range. So I started probing around with my scope probe, and I pretty quickly discovered where the problem was located. Let me show you what I found. Okay, so here's the schematic for the A1 assembly, as well as some of the um, uh, chassis-mounted parts that are not on the A1 assembly, like the range switch here. Um, so I started by probing around while switching the range switch from the 10 volt range to the 100 volt range. Now, when it's on the 10 volt range, uh, this switch will apply negative 35 volts through this resistor R36 to the base of Q8. So negative 35 volts on the base of this Q8 PNP transistor should turn it on, pulling the collector uh, down towards ground, or up, I guess you would say, from negative 35 volts up here at the VCC, negative 35, down towards ground. But when you turn on this Q8 by applying negative 35 volts through the resistor to the base. When you switch it to the 100 volt range, it grounds that same R36 resistor, which will turn off this Q8 and should send the collector up or down, I guess you would say, towards negative 35 volts, because Q8 is turned off. That voltage, that VCC negative 35, goes through the coil of this relay A1K1. So when I probed on the base while switching between 10 and 100 volt ranges with my scope probe, I do see a corresponding shift in the base voltage. That means that this wiring from the switch to the base of Q8 is all good and fine. And I also noticed a similar change in the emitter voltage on Q8. When I looked at the collector voltage of Q8, I measured close to 0 volts all of the time. I concluded that there's no way that the negative 35 VCC is ever getting to the collector of Q8. In fact, there's likelihood that either this resistor is open or the relay coil itself on K1, the relay coil is open. And that's why we don't ever have, even though we try to turn off Q8, its collector never goes to negative 35. And it turns out that is what we have found. The coil on relay K1 is open. When you measure between these 2 points on that relay coil, it's an open circuit. Now, this is particularly bad news because this relay, of course, is 60 years old, and we won't be able to find a direct replacement for it. It only leaves two options. Option number one is to try to find a similar enough relay with similar coil characteristics and contact characteristics that I can adapt to use in this position for relay K1. I will have to readjust the pinouts and make it fit somehow. That's option number one. Option number two is to attempt to perform surgery on the coil, the solenoid coil of the relay K1. Try to find where the open is inside of that coil. prospects for being successful in doing that are not very good, but seems to be one of the only two options I have available. So I'm going to attempt to do that. Okay, so here we have relay K1 unsoldered from the A1 assembly, and I have it clamped in my circuit board vise, my PANA vise, in the rubber jaws very carefully, delicately clamped in place in an upside down manner. You can see this is the contact. This is the switches between normally closed and normally open contacts. When the coil is energized, you can see how it switches. Um, these two contacts are what are soldered into the circuit board for the coil connections. If I measure with my ohm meter between those two terminals, we have an open circuit, and that should not be the case. This should have a resistance, according to the manual, this should have a resistance of 5 kiloohms between here and here, through that coil. So it's a 36-volt relay with a 5 kiloohm coil. All right. So that's something like, I don't know, whatever that turns out to be, 7 milliamps of current to energize the relay. So when I look through the possible options of purchasing a suitable replacement, Mouser Electronics is what I went to. They did have some sort of relay that has similar coil characteristics and similar contact characteristics, even though it doesn't look anything like this relay. So I placed an order for a couple of those relays. They were very inexpensive. I have no idea what they will actually look like when they come in. But I placed an order for a pair of them because they were very cheap, and so I figured I could always use a spare. Those might work. I might be able to get them to work, but I'm also going to very carefully attempt to find the break in the coil wire inside this relay. Um, I've never tried anything like that before, but it seems to be what I might have to resort to here in this case. So we're going to do that now. Okay, so I've zoomed in as close as I can with my camera. Perhaps I can try to do it with my microscope. We're going to try to just do it with the camera for now. I've very carefully peeled back the tape that was wrapped around the solenoid, at least to a beginning point. And we can see here, this wire is the wire that's actually connected to the terminal that's soldered onto the board. Okay, and if you look very, very closely, there is a very fine copper wire that starts over here, goes here, and is wrapped around this little braided wire. Okay, and that is the end of the coil wire, this extremely fine copper wire right here. Now, it's possible that right here is where the connection is not being made. I do have continuity from this terminal up to this silver colored wire. I don't know if it actually makes connection to the copper wire yet, and I'm not sure exactly how I can measure that. But this may be where the break is, right here. Chances are, in these situations, it's near one end or near the other end. So here is one end, and we can see what it looks like, and it seems like it's soldered to this silver colored wire. Seems like the copper wire is soldered to this silver covered wire, even though it is wrapped around it, and it seems to be partly loose over here. There is plenty of solder in between there and there. So this is probably making connection, although I can't tell for sure. And there's a lot of adhesive in here. I don't want to be too aggressive with peeling back this tape, because I may just damage the copper wire right there at that point. So I don't know, but this is what one of the terminals looks like. We're going to flip the relay around and look at the terminal on the other side now. Okay, looking at the other side now, I have peeled back the adhesive tape as best as I could again, and it was very difficult, but it was a very delicate operation. Now here's the other terminal that's soldered onto the board, and there is a very, very tiny piece of that braided silver colored wire right there that is soldered directly into this terminal, and those there is continuity from that wire to this terminal. Um, Very, very hard to see in the image um, through my camera. And because my eyes aren't as good as they used to be, it's hard for my eyes to see this too. But if I'm very careful and look where the tip of my screwdriver is, that is where the end of the coil comes out and attaches to the braided silver colored wire. Um, it seems like it is actually still connected to the terminal at that point. Um, I'm not really sure. I'm going to try to peel back some of this tape a little bit more and see if maybe I can't make a clearer, um, get a better idea of where the break may be occurring in this coil. I may not be able to fix it. I don't know. And now we're looking through my microscope. This is the terminal that solders onto the circuit board. And there's the base of the relay. And coming out through that is the little piece of the braided silver colored wire that forms one end of the coil connection. Now, it's almost impossible for me to tell if there is a copper wire somehow soldered to that silver braid. You see, there's still a small piece of tape and a big blob of adhesive right in that same area. And I can't tell for sure if there's a copper wire there or not. Um, and of course, above it is the windings of the copper wire of this solenoid around the plastic bobbin on this relay. I really just can't tell if there's a connection there or we're missing a wire altogether. It's close to impossible for me to tell. So, unfortunately, I have a feeling I will not be able to repair this relay without destroying it. Um, so, hopefully, the replacement relay that I have ordered will somehow fit in that circuit board space, and I'll be able to wire it up. It seems like the coil characteristics will be similar enough that it'll probably function electrically if I can get it to work physically in the space on that board. So we'll have to see when the relay comes in. Okay, so I have disassembled the relay a little bit further. I removed I don't know what it's called, the armature or whatever, the moving contact um, from the relay so that I could uncoil the fine copper wire from the bobbin. And here I wanted to demonstrate just how fine the wire is. On the left, you can see the copper wire, one strand of the copper wire, and on the right is one strand of my hair that I pulled right out of my head, which is probably a bad idea because I don't have that many hairs left at my age. But this is one of my hairs, and this is the copper wire. And you can clearly see that the wire is finer than a human hair. So I don't know what the gauge or the thickness of this wire is, um, but it's very, very fine, probably on the order of 2/1000th of an inch thick or something like that. Um, so anyway, I was able to measure one end of the copper wire. Um, I took a piece of sandpaper and very carefully sanded off the enamel insulation off the wire and clamped my ohm meter onto that bare copper. And then I tried to measure to the contact on the other end of the coil to see if I had continuity. And in fact, I did not have continuity. So the break is somewhere inside the middle of the coil, and that means that I won't really be able to repair the coil on the relay. But it's a few days later, and the relays that I have ordered did come in, and this is what they look like. About half as large, which is fine. The pinout, of course, is completely different. Doesn't match at all. I'm sure I can figure out a way to make it work in the circuit board. However, I have measured them, and so I can have determined what the pinout is on this relay, and I'm sure I can wire it up so that it'll work to replace the defective one. So that's what I'm going to do now. Here's what I've come up with. I took a tiny piece of perf board, and I soldered the relay onto it, and with some flying leads that will match up with the holes on my A1 assembly. It's not the prettiest thing I've ever seen. Nothing to brag about, but I'm sure this will get the job done. Let's solder it onto the A1 board and see what we've got here. Well, I'm not sure that it actually meets Hewlett-Packard quality standards, but I imagine it will probably work. Just don't look at it too closely. All right, let's put it all back together and see what we got. Okay, here we go. That's the 10-volt range. Will it switch when I switch to 100-volt range? Watch the decimal point. Wow. I think I fixed it. I'm sure that I fixed it. How about the 100 millivolt range? Here's the 1000 millivolt range. That's correct. 100 millivolt range, it's switched to here. It does switch. I think it's fixed. All right. Very good. Now I have it set to auto range, and let's see if the auto ranging works. I'm a little bit above 10 volts, so it's in the 100-volt range. That seems to be correct. As I drop it down below 10 volts, it switches to the 10-volt range automatically, just like it's supposed to. Let's see what happens when I drop it down below 1 volt. Drops down to there's the 10-volt range. And there is the 1000 millivolt range, which is the 1-volt range. If I drop it down even further, below 10 millivolts, below 100 millivolts, it drops to the 100 millivolt range. Above 100 millivolts, it goes back to the 1000 millivolt range. Above 1 volt, it goes to the 10-volt range. Above 10 volts, it goes to the 100-volt range. Auto ranging works. All right, the instrument is fixed. I can't test the 1000-volt range because I don't have a power supply that goes up above 100 volts. But anyway, except for that, the instrument is fixed. So off camera, I'm going to do a complete realignment and a calibration of this thing. But I believe we have a completed repair. So that will do it. This is the 3440A Deja Vu model. And I am very happy to see that it works perfectly. All right, guys, that'll do it. Thank you very much for watching. Please like and subscribe so you don't miss any more of my videos. Thanks again.